All right, let's go over these problems here. Okay, and what kind of question is this? This is a what? Expected value. So what do you know about the expected value? How do you solve an expected value problem? Right? This is what I'm talking about. When you go home, you're going to review that. What's the format that you use? Mu, also known as mu, which is the expected value of the random variable x, is equal to what? It's the summation of x times p of x, and you do this summation and this product over all the outcomes. Okay? So here's the deal. When you read that question, that triggers what you should do. But you have to know that relationship in order to answer the question, right? So that's where you start. If you're thinking of expected value and you're hoping something's going to come to your mind and it won't, you have to know that definition. Okay? So what kind of problem is this? Is this sort of a gambling problem? It's a gambling problem, right? So as a gambling problem, you can think of this in some sense as having only two outcomes. Because when you gamble, you can either win or you can what? Lose. And this is we're looking over all possible outcomes here, all x. Okay? So what do you do next if we look at the outcomes here? These are our outcomes x. We have to answer p of x, which is the probability of those particular outcomes. So this is where people start to go, probability, what is that? All those weeks and all those homework problems that you guys did, that we talked about probability. All that work that went into probability is going to pay off now, right? Is that right? Exactly, that's the idea. So, okay, what's the probability that you win? How do you win this game? Yeah, the probability that you win if you select what? At least two what? Blue marbles. Is that right? That's how you win. So this is an at least, oops, is at least two? Uh-oh, did I make a mistake? I wrote this question without my coffee. No wonder you guys are looking at me like I'm nuts. Okay, I forgive you now. I forgive you. Before I didn't forgive you. I thought, what's wrong with these guys? You guys look at me like I'm crazy all the time. How many marbles are you selecting? Well, no, they're saying, okay, yeah, I wrote it wrong. Sorry. If you selected at least two blue marbles, this is, yeah, but you have to have a number of marbles you're selecting. I'm sorry, you don't have a context. Oh, it's my fault. No wonder, okay. Let's reword it so you can actually answer it. You can't really answer it this way. You guys know that you can't answer it. We're going to have to do this. If you select it, here's the game, bag of marbles. You are going to select, okay, two different marbles. Okay, you select two different marbles. You win. You can win this game if you select, this is where my wires got crossed. This is where the wires got crossed, sorry. At least what? One marble. Yeah, the way it was worded, you can't answer it, so, okay. Sorry. I guess it helps to have a clear question. So you're going to select two different marbles, right? Good, I'm sorry, two different. So you win this game if you select at least one blue marble at random. Okay? You could just leave it that way. If you select at least one blue marble at random, then you win $25. Okay. If you select at least one blue marble at random, then, all right. I'm sorry. I got those two wires crossed. There you go. Now you can answer it. Does that feel better? Exactly. Exactly. So, how do you answer an at least one question? You guys remember? 1 minus the probability of selecting what? No blue what? Marbles, right? Okay, 1 minus the probability of selecting no blue marbles. We've been doing this over and over and over again. And so how do you determine this probability here of no blue marbles? You guys remember? How do you select that probability? Well, why do you have two fractions? Because you're selecting what? What are you selecting? 2 marbles. Aren't you selecting 2 marbles here? 2 fractions. So you reach in the bag. If none have to be blue, that means the first can't be blue and the second can't be blue, right? So what's the probability of selecting a non-blue marble from that bag? 30 out of 34. Good. What do you do with that non-blue marble you just took out of the bag? Why is it out the window? Because they're saying 2 different marbles. That's the tip-off. You know, in the test last week, people ask, hey, psst, yeah? Is this with or without replacement? And what did I say? Huh? You say, I don't know, do the best you can. No, I said, what does it say? Different? I say, okay. So that tells you, right? I didn't answer the question. So that should tell you if it's 2 different marbles, that has to be without replacement. So you reach in the bag again. What's the probability you select a non-blue marble? Well, there's 1 less, meaning there's 29. And there's 1 less marble, meaning that's 33. So here's what I'm saying. You could be asked an expected value question when determining the probability that you win isn't so what? So simple to do. So go on. This is a probability to select at least 1 blue marble. So what's the rest of the computation? What is that, right? Right, so it's going to be 1 minus 0.775. Oh, how nice. So that probability is going to be 0. What? Is that 225? Is that right? So this is the probability that you win is 0.225. Note, what's the probability you lose? Let's see, what is that probability? Isn't that probability harder to determine? What do you think? Is that harder to find? How do you find that probability you lose if you know the probability you win? Anybody know? Besides me and Moshi? How do you find the probability you lose when you're given the probability that you win? What is it? The complement rule. Good. Okay, good. Probability you lose is 1 minus the probability that you win. By that complement rule, so we just determined the probability you win. That's what? 0.225. So the probability you lose is 0.775, okay? So here it is. But notice this. Notice this. Isn't this the probability that you lose already? I mean, that number you say, that looks familiar. I've seen it before. Yeah, it's no coincidence. It's the same number right here, which is the same probability you just found right here, which is the probability that you select no blue marbles. So by this problem, in